In this video, we're going to build a first-person controller in Unity using the new input system. A setup like this works for all kinds of games like shooters, horror games, puzzle games, and pretty much anything where the player moves around in first person. One nice thing about the new input system is that we can support both keyboard and mouse and a game controller without writing separate input code for each device. So let's get started setting up the input actions. I've created a new 3D URP project. Before we do anything else, make sure the new input system is enabled. So go to Edit, Project Settings and Player. Scroll down to Active Input Handling and set it to Input System Package New. Unity often creates an input system actions asset automatically, but if you don't see one, you can right-click in the project window and choose Create Input Actions. Open the asset and you'll see that Unity has already created several actions for us. Select Move. On the right, notice that the action type is set to Value. That means that this action returns a value continuously while the player is pressing movement keys or moving a stick. The control type is Vector 2, so the action gives us two numbers, one for horizontal movement and one for vertical movement. Expand the Move action and you'll see its bindings. These are the actual inputs that can trigger the action. By default, it includes the left stick on the gamepad, WASD, arrow keys, a joystick and an XR controller input. If you click a binding, you can see its path, which points to the specific input device and control. The WASD binding is a little different from the others. It's set up as a 2D vector composite. Expand it and you'll see separate entries for WASD and the arrow keys. Unity combines those individual buttons into a single Vector 2 value. For example, the W key, which contributes in the up direction, and D contributes to the right direction. That means pressing W and D together automatically gives us diagonal movement without any extra code. Now select Look. This action also returns a Vector 2. And it already has bindings for the right stick on the gamepad, the mouse movement, and touch or joystick look controls. The mouse binding uses pointer delta, which is simply how much the mouse has moved since the last frame. Next is jump. Notice that its action type is button instead of value. For movement we need a continuous value, but for jumping we only need to know when the player is pressing down the button. The sprint action works in the same way. It's a button with bindings such as left shift on keyboard and the left stick press on the gamepad. If you ever need another input, click the plus button on the right side of the input actions window. You can choose whether the action is a button, a value, or a pass-through action. Right-clicking the action lets you add bindings and assign them to specific control schemes. For this controller we already have everything we want, so we don't need any extra actions. So now that the input is ready, let's use it to build the actual first-person controller. Alright, I've set up a simple test scene with a plane and a few objects. I'm using the free Gridbox prototyping materials from the Unity Asset Store, and I'll leave a link in the description if you want the same setup. In the hierarchy, create an empty game object and call it player. You set its transform, and I'll also set the tag to player. The tag isn't required, but it can be useful later if other scripts need to find the player object. Now right-click the player object and create a 3D capsule as a child. You can replace this with any character model you want later. Remove the capsule collider from the capsule itself and move it up so its Y position is 1. Instead, add a capsule collider to the parent player object. Set the center to 0, 1, 0 and the height to 2 so it properly surrounds the player. Next, add a character controller component to the player object and set its center Y to 1 as well. We'll use the character controller for movement and collision handling, which is much simpler than setting up a rigid body for a basic FPS controller. Drag the main camera onto the player object so it becomes a child, then move it up to roughly eye level. Now let's create the movement script. In the scripts folder, I'll create a new model behavior script called player controller, attach it to the player object and open it up in your code editor. Because the script depends on the character controller, I'll first add this line above the class. Require component, type of character controller. That way Unity will automatically add the component if it's missing. We also need the new input system namespace. So let's add using unityengine.input_system. Now add a few serialized fields for movement. I'll add a serialized field, private float called walk speed, which by default I'll set to 5.5, and a serialized field, private float called running speed, which by default is set to 9. These control the normal movement speed and sprint speed. Add jump and gravity settings, so let's add a serialized field, private float jump force, which is set to 8, and a serialized field, private float called gravity, which is set to 20. Using serialized field keeps the variables private, while still letting us edit them in the inspector. Create a private camera called main camera, and a private character controller, which I just call character controller. And then I'll add a reference to the input actions, so I'll create a private input action called move input and do the same for the run and jump input. Finally, add a few variables to keep track of the movement state. I'll create a private float current move speed, a private vector tree called move direction, and a private float called look angle. In start, initialize everything. So in the private void start, I'll first assign the main camera becomes getComponent in children camera. Character controller becomes getComponent character controller. Next we'll assign the input action, so let's do moveInput equals inputSystem.actions.findActionMove, and then do the same for the run and jump inputs. I don't want the cursor to be visible on screen, so let's do cursor.logState equals cursor.logMode.locked, and cursor.visible equals false. And finally, we'll set current move speed to be equal to walk speed. For this tutorial, I'm keeping input, movement and camera control in one script so it's easier to follow, but in a larger project, I'd recommend you to separate concerns and moving those into different classes. In update, we'll first read the input value, so let's go vector2 called moveVector, which I'll set to moveInput.readValue as a vector2. The move action returns a vector2, while sprint and jump return button values, so we'll be handling those in a different way. Next I'll create a handle movement method, which will take in a vector2 called moveVector, and then we'll call it from update, so let's call handle movement, and we'll pass the moveVector as a parameter. Passing the moveVector as a parameter keeps the code cleaner than storing every input as a separate field. Inside handle movement, we'll start by getting the player's local forward and right directions. So let's create a vector tree called forward, which is set to transform the transform direction vector_tree.forward, and then do the same for right. We can then save the current vertical movement, so we can preserve it while we move horizontally. So let's create a float Alt-Y, which I'll set to the current move direction.y. Then we'll calculate the new horizontal movement speed by doing vector2 new speed becomes a new vector2 with moveVector.y multiplied by current move speed, and then moveVector.x multiplied by current move speed as well. The move vector uses x for left and right and y for forward/backward, so we swap them here to match world movement. Now we'll build the movement direction by doing move direction equals forward multiplied by new speed.x plus right multiplied by new speed.y, and then we'll set move direction.y to the old y value for now. And finally we need to move the controller by doing character controller.move, which will take the move direction multiplied by time.delta time. Save the script, return to Unity, make sure the player controller is attached to the player object and press play. At this point the player can now move around the scene, but we still can't look around or jump. So let's add jumping next. Now because jumping is a button press, it will work a bit differently than moving around. So first I'll add a new variable, which will be a private bool called jump, which I'll set to false, which will keep track of whether the jump button was just pressed. Now let's create a new button called private void called jump, which will take in an input action that callback context, which we don't actually need the value of. And in here we'll say jumped equals true. This method will be called automatically when the jump input starts. Then in start we need to subscribe to that event. So let's do jump input that started plus equals jumped. So whenever the player presses the jump button, the jump method runs and sets jumped to true. Next go into update, and we'll add if not character controller that is grounded will set jumped to false. Once the player leaves the ground, we reset the flag, so holding the jump button doesn't keep triggering jumps in the air. Now let's go into handle movement. First we'll remove this line and then replace it with if jumped and character controller that is grounded. Then we'll set move direction.y to jump force, and else we'll set move direction.y to the old y. Which means that if the jump button was pressed and the player is standing on the ground, we apply the jump force. Otherwise we keep the previous vertical movement. You can also write the same logic in a shorter form using the ternary operator, which is what I'll be doing. Both versions do exactly the same, but I prefer the second one because it's less lines of code. Now we'll add gravity. So under that jump check we'll add if not character controller that is grounded, I'll do move direction.y minus equals gravity multiplied by time.delta time, which gradually decreases the vertical speed while the player is in the air, which means that the player will fall back down. Now let's save the script, return to Unity, and make sure jump force and gravity are not set to 0 in the inspector. Then press play and test it out. You can see that the player can now move around and we can jump. Before we move on to camera control, let's add sprinting. So in update, before calling handle movement, I'll say current move speed equals run input that is pressed, which will be set automatically when the run input button is pressed, and if so we'll set it to running speed and else to walk speed, so again using the ternary operator. Now that we can move and jump, the last thing we need for our FPS controller is looking around. Reading mouse input with the new input system is actually very similar to how you would do it with the old input system. Inside update, let's create a new vector2 to store the mouse movement. So I'll create a vector2 called mouse delta, which is set to new vector2, which will take in the mouse.current.delta.x .read value, and then the same for the y-axis. The delta value gives us the amount that the mouse has moved since the previous frame. So if the player moves their mouse to the right, the x value increases, and if they move it upwards, the y value increases. Just like with movement, I'll put this logic into its own method. So let's create a private void called handle looking, which will take a vector2 called mouse delta, and then we'll call it an update after handle movement. Now inside handle looking, we first need to update the vertical looking angle. So let's go look angle plus equals negative mouse delta.y multiplied by look sensitivity sensitivity. We multiply this by look sensitivity so we can control how fast the camera moves. The negative sign is needed because mouse movement and camera rotation actually work in opposite directions. For example, when moving the mouse upwards, we want the player to look upwards and not downwards. Next, we need to make sure the player cannot look completely upside down. So we clamp the value by doing look angle equals mevf.clamp. We will clamp the look angle between negative look angle limit and look angle limit. This limits the vertical rotation between our negative and positive look angle limit. Now we can apply this rotation to the camera by doing main camera.transform.local rotation equals quaternion.euler, which will be look angle on the x-axis and 0 on the y and z-axis. Since the camera is a child of the player object, rotating it locally only affects the up and down looking direction. For the horizontal rotation, we actually want to rotate the entire player object. To do this, we'll do transform.rotation times equals quaternion.euler with 0 on the x-axis, mouse delta.x multiplied by look sensitivity on the y-axis and 0 on z again. This rotates the player around the y-axis, allowing us to look left and right. Now save the script and head back into Unity. Make sure that both look angle limit and look sensitivity are not set to 0. The sensitivity value goes very fast very quickly, so you'll probably want to use a very small number here, and I'm using 0.2. Now we can press play, and there you go. We have a fully working first-person controller. We can move, jump, sprint and look around. From here you can start adding extra features like crouching, sprinting, stamina or interacting with objects. But the foundation of an FPS controller is now complete. If you enjoyed this video, be sure to like and subscribe since it really helps me out. If you have any video ideas that you want me to make, be sure to leave them in the comments. Anyway, I'll see you guys in the next one.